Welcome back from spring break. We are now in April. We are in our 12th week. Just a heads up that we are about 2 months out from the end of the school year. I know sometimes it's hard to get back into the groove of things after we are on a week break, but I think that this is a good reminder that the end of the school year is coming soon. So 2 months is going to go by really fast. There's some fun things coming in the last couple months of school, so finish strong. Start setting some goals about where you want to finish this school year, and then work on finishing strong. I do have a warm-up to get us thinking back to what we were doing before we left for spring break, where we were solving systems of equations. Remember, where we want to find a solution that will work for both the equations that we have. So here, we have a warm-up question that relates to solving a system of equations where we're actually not going to solve this system of equations, but instead we're going to focus on how many solutions will the system of inequalities, how many solutions will the systems of equations have. So remember, your hint is to look at the slopes and the y-intercepts, I should say, to help us determine the number of solutions. Remember, before we left on break, we looked at how we can graph systems of equations to see what the solution was. So go ahead and see if you can't jog your memory. And you should have your math notebook out. Remember, you should be taking notes, and I will give you points for taking notes, so take advantage of that offer. Go ahead and click pause and try and solve that, and when you're ready to check your work with mine, go ahead and click play. All right, so remember, we did look at how we can actually solve by graphing, where we would look at both of our equations and we would graph both of our equations on in a coordinate plane and see where our lines cross or intersect, and that would be the solution. But sometimes, so where we would have one solution, that would be if we would graph both of our lines and they did intersect. So if we graph both of our lines and we find that they intersect, that is an example of where we would have one solution. And in that case, where we have one solution, we have to have our lines intersecting. In order for our lines to intersect, they would have to have different slopes. We also looked at how sometimes we might have, I'm going to graph this case in blue, we might have two lines that are parallel to one another, just like these two lines that are in blue. And in that case, they're never going to intersect because they're parallel. And remember, we know parallel lines have the same slope. They have different y-intercepts. They cross the y-axis at different places. But in this case, they're never going to intersect, so we wouldn't have any solutions. And then the last case is that if we were to go and graph our lines and find that the lines were graphed right on top of one another. So we would have one line and then another line right on top of it. And in that case, we would have infinite number of solutions. We would have infinite number of solutions because the line is the same line. It has the same slope and the same y-intercept. So essentially, it is the exact same line, and thus, in that case, we would have an infinite number of solutions because all points on the line would be a solution. So just a reminder of just what we talked about. So going back to our warm-up problem, let's look at this system of equations. So what is the slope in our first line? What is the slope of our first line? It's -3, or it's -3/1. If we like to write slope as a fraction, so we get our vertical and horizontal movement. What about the slope in line 2? It's also -3. Remember, the slope is the number that's attached to the x. So this is the number that's being multiplied by the x as our slope. So we can see that we have the same slope. What about the y-intercept? What is the y-intercept of our first line? It's 7. Remember, it's our constant number. What about the slope, or I'm sorry, the y-intercept in our second line? It is 5. So we have the same slope, but we have different y-intercepts. So that means that when we go to graph our lines, we're going to see that really what we have going on is two sets of parallel lines. We've got two sets of parallel lines, which means they're never going to intersect, so we would have no solutions. No solutions. No solution, I should say. So that's a good review of what we did before break. And now I'm going to move on. So this week we're going to continue to explore solving systems of linear equations. We learned that we can solve by graphing. We did that before break. This week we're going to focus on two new methods, elimination and substitution. And you might see elimination called combination as well. So sometimes you see that method that you're going to learn about as combination method or the elimination method, and it's going to make sense by the end of this recording. So let's get going. So just an example, or just a quick reminder of what a system of equations is. It's a set of equations where we have two or more equations. For this class, we're only going to be doing two equations. So we have a set of two equations, and we're trying to find a solution that when we plug in for x and y into both equations, it makes our system equation true. It works for both equations. For example, this system of equations here that I just put up as I was chatting, the solution is 3, 0. That means that the x is equal to 3 and y is equal to 0. And when we plug that into both equations, we will find it true. So we're going to go ahead and check that. I'm going to move stuff around here so that we can do that math. Move this up a little bit. All right. So my solution is 3, 0, which again means that x equals 3 and y equals 0. So whenever I see a x, I'm going to plug in 3. And whenever I see a y, I'm going to plug in 0. And check my math. 2 times 3 is 6. 6 plus 2 times 0 is 0, which means that's the same thing as saying 6 plus 0 equals 6. That's true. So it worked. So plugging x equals 3 and y equals 0 into the first equation worked. It came out that it equaled to 6. Now let's do the second equation. So 4 times 3 minus 6 times 0 should be equal to 12. So I know that 4 times 3 is 12. I know 6 times 0 is 0. 12 minus 0 is 12. And we were trying to get it equal to 12. That worked as well. So that solution of 3, 0 worked for both equations. So that's what we're trying to do when we solve a system of equations, is find a solution that satisfies both equations. All right. So another method that we can use in addition to graphing is substitution. So last week we learned about graphing. Now we're going to learn about the substitution method. So to use the substitution method, what we need to do is first, step 1 is to solve one equation for one variable. So we want to get one variable solved for in one of our equations. So look at our system of equations here. We've got y equals x plus 3, x plus y equals negative 5. So step 1 again says solve one equation for one variable. Well, this is already done for us. Look at that top equation. It's got y equals. And that's what we want when I say solve equation for one variable. We want y equals, or we want x equals. But we want one variable all by itself on one side of the equation and then all these stuff on the other side. So step 1 is already done in this case. So this would be a good example of a system of equations that we could use substitution for because it's already done. One of our equations is already solved for y. So now our step 2, is that the same? All right, so now step 2 is going to be, so now we're ready for step 2, which is where we do the substituting, where we're going to substitute. So what we're going to do is we've got our first equation solved for y. So what I'm going to do is wherever I see a y in my second equation, I'm going to substitute in the fact that y equals x plus 3. So whenever in my second equation, I'm going to plug in my first equation. I'm going to substitute in that value for y. So my second equation is x plus y. Oh, instead of putting in y, I'm going to substitute in what I know y equals from my first equation. Y equals x plus 3. I'm going to plug that right in for the y in my second equation. And then I set it equal to -5 because I'm plugging it into that second equation. So what I did by using substitution was I only have one variable to solve for. You can only solve for one variable. So now I only have x's. So step 3 is I'm going to now solve for the variable. I'm going to solve for the variable. I should say solve for the variable. So I'm going to solve for x. I'm going to combine my like terms. I've got 2 x's, combine those together. So I've got 2x plus 3 equals -5. And now I'm going to work on solving for x. So I'm going to use my algebra skills where I'm working on, I want to get x all alone. And remember, we want to move the terms that are farthest away from the x term first. Or we want to do opposite of PEMDAS, so we want to add or subtract first. So I'm going to move this 3 to the right side of the equation. It's being added, so to move it, I'm going to do the opposite. I'm going to subtract 3 from both sides. So then I'm just left with 2x on the left side of the equation. -5 minus 3 is -8. And then I'm going to solve for x. By last step, I've got 2 times x, so the opposite of multiplying is dividing. So I'm going to divide each side by 2. And that gives me x equals -8 divided by +2 is -4. So then I get the value of x. X equals -4. Then my last step is to solve for the other variable. By plugging into the first, by using the other equation, I should say, using other equation. All right, so what I'm going to do is I'm going to go back to that first equation. My first equation was y equals x plus 3. That's really nice. It's going to help us solve for y because I know y equals x plus 3. So I'm going to use that equation that we started with to help us solve for y. So y, I'm going to go up here because I'm running out of space. I know x now. I'm going to substitute in -4 for x and then add that plus 3. So I'm using this equation to help me. So y is going to equal -4 plus 3, which is -1. So here is my solution. Remember, I have 2 solutions. I have a solution for x and a solution for y. And we can write our answer, our final answer, let's change our font to green, as a coordinate. So I could write -4, -1. That's my final answer right there. Just combine it as a coordinate. So I'm going to go on to the next slide where we're going to do another practice problem with using substitution and get better at doing these. So if you need more time, go ahead and click pause so you can take good notes. All right, so we're going to solve the system of equations using substitution, just like we did before. We can ignore this. Oops. Ignore these. Let's see here. So I wanted to get rid of the dots so that they weren't confusing. So we want to solve the system of equations using substitution. So first, our first step is solve an equation for one variable. So looking at those, do we already have an equation that's solved for a variable? We do. This equation right here, y equals 3 plus x, is already solved for one variable. Now we can do the substitution where we're going to take our first equation and plug it into we're going to take our second equation and plug it into our first equation. So whenever we see a y in our first equation, we're going to plug in x plus 3 because that's what y is equal to. Y equals x plus 3, or 3 plus x. So whenever we see a y in our first equation, that's what we're going to plug in. So we're going to do the substituting. So we have x plus, there's my y, so now I'm going to plug in 3 plus x and set it equal to 5. So remember, we're using our first equation, we're just substituting in 3 plus x for y, so it's still equal to 5. And then we want to solve our equation. So let's go ahead and do that. I'm going to change my font color to black so I can write in here. So combine our like terms. We've got 2x's plus 3 equals 5. I want to work on solving, so I'm going to subtract 3 from both sides. I get 2x equals 2. And then to solve, divide it by each side by 2, and I get x equals 1. So that's x. We're not done. So we're halfway done. So we know what x equals, but we still need to find what y equals. So remember, we can use that second equation now where it says y equals 3 plus x. We can use that to solve for y. We know what x is. I know x is equal to 1. So then y would equal 3 plus 1, which is 4. So y equals 4. So we are done now. We've solved for both variables. So the final answer would be, if we write it as a coordinate, it would be that x equals 1 and y equals 4. We can check our work to make sure we did it right. Plug each of our values into our equations. I'm going to erase what we have up there. So we have x is 1. Y equals 4, 1 plus 4 equals 5. That works. We did that right. Y is 4 equals 3 plus x. X is 1. 3 plus 1 is 4. 4 equals 4. So we did that right. So you can always check your work. That's what's cool about these. You can turn around and check your answers, plug it into both equations, and see if it works. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Let's do one more. So solve by substitution. It's what we did. Here we go. Solve by using substitution. So in these two equations, I'm looking and I don't see that either equation is solved for a variable. So we're going to have to do that. So we're looking at both these equations. Would it be easier to solve for one variable in one equation than maybe one of the others? So I'm looking at the top equation and I see that there's an x. So that's going to be really easy to solve for because all I would need to do is move the 3y to the other side of the equation, and I can do that by subtracting. So what I'm going to do is I'm going to solve for x in the first equation by subtracting 3y to the other side of the equation. So now I've solved for a variable. So now, wherever I see an x in my first equation, I'm going to plug in 7 minus 3y. So let's go ahead and do that. So we would have 4, I guess we could do that down here, 4 times, here's my x, so now I know the x is equal to 7 minus 3y, minus 2y equals 0. So now I'm going to solve my equation. I'm going to solve for, let's start over. My third step is to solve the equation. I'm going to solve for y. So I've got a 4 in front of my set of parentheses, so I have to distribute. That's my first step, is to distribute. So 4 times 7 is 28. 4 times negative 3y is negative 12y. And then I'm done, and then I've got this negative 2y equals 0. So work on solving. Combine any like terms. I see I've got 2y terms, so I'm going to combine my y terms. Negative 12y, and take away 2 more y's, and I've got negative 14y's equals 0. Working on solving for y, so my next step is to subtract 28 from both sides. Then I'm left with negative 14y equals negative 28. My last step is to divide negative 14 from both sides. Running out of room down there. So negative 28 divided by negative 14 is y equals 2. That's what we end up with, y equals 2. Negative 28 divided by negative 14 is 2. So we've got y equals 2. But remember, now my last step is to solve for the other variable. I need to solve for both variables. So now I'm going to solve for x. So I can choose either equation. I can choose either equation to solve for x. So I'm just going to use the top equation where it says 3y plus x equals 7. Remember, I know that y equals 2. So anytime I see a y, I'm going to plug in 2. And then I'll solve for x. So 2 times 3 is 6. 6 plus x equals 7. Subtract 6 from both sides. X equals 1. So there's my final answer. Written as a coordinate would be 1, 2. So that's my final answer. So that is how you use substitution. That's how we use substitution. You'll learn more about that this week in your Edgenuity lessons. And the other method, oh, here we go. Let's talk about how we, the steps just one more time, reiterate what we just learned. So to use the substitution method, the steps we're going to use is first, you solve one of the equations for one of the variables. Then you substitute the expression that you just found in step 1 into the other equation. Then you solve for the variable. Then you need to make sure that you use the value that you just found from step 2 and to help you find the other remaining variable. All right, we're going to move on to the elimination method so that we don't make this recording too long, which is sometimes referred to as the combination method. So to use the elimination method or the combination method, combination means to add two things together usually, right? So what we're going to do is we're going to add the equations together to eliminate a variable. Because remember, we can't solve an equation that has two different variables. So looking at this top equation, 2x plus 3y equals 20, it's impossible to solve that equation because we've got two different variables. So we can only solve an equation when we only have one variable. So we can use the combination method, which means we're going to add our two equations together so that we eliminate one of our variables. So look at right here. So look at this. If we combine or add these two equations together, they're nicely lined up, our x's and our y's. Look what happens to our x's when we add these two equations together. We've got 2x plus negative 2x. X minus 2x is minus 2x's, there's no x's left. They're gone. They're eliminated. Now we've got 3y's plus 1y, so we are left with 4y's. And then we continue on, 20 plus 4 is 24. So now look, we've got 4y equals 24. We've eliminated the x's, and now we can focus on just solving for the y's. So 4y means 4 times y, so to undo that, we're going to divide each side by 4. So that would give us y equals 24 divided by 4 is 6. And then just like we did before, we also then need to plug in that value so that of y so we can solve for x. We can use either the top or bottom equation. It doesn't matter. you'll still get the same answer. So I'm just going to use the top equation. So 2x plus 3, y we know is 6 equals 20. And then we're going to solve for x. So 2x plus 18, 3 times 6 is equals 20. Subtract 18 from both sides. We get 2x equals 2. 20 minus 18 is 2. Then final step is to divide each side by 2, and we get x equals 1. So the final answer would be x equals 1 and y equals 6, written as a coordinate. So you're going to learn more about doing this. That's the last problem I'm going to do for the recording, but I do want to remind you that when you use the elimination or combination method, you are we're adding the equations together. And to use the elimination or combination method, we need to make sure that we line up our two equations so that our x terms are lined up, our y terms are lined up, and our constant terms are lined up. You'll see more of that this week. So we learned about 3 methods to solve equations. Last week was the graphing, this week was substitution and elimination. So that's a wrap. Let me put up your key phrase assignment. So we learned in order to use substitution method, the first step is that we have to solve our equation, one of the equations, for a variable. So is this equation written where it's solved for a variable already? Is this equation x equals 2 y minus 6? Is that already solved for one of our variables? So could we start solving for a system of equations? Is this written where we're solved for in a variable, or would we have to move things around? So that's your question. Have a great week and let me know. And you can answer that yes or no and explain why. Yes or no and explain why. If you have any questions, let me know. Otherwise, have a great rest of your week.